Good everyone, my name is Graphics. Today we want to study another aspect of differentiation, which is chain rule. Now, we know chain rule, we use chain rule when we are dealing with functions that has power, and also we use chain rule when we are dealing with logarithmic equations and exponential equation. Even in trigonometric functions too, we use chain rule. So I'm going to analyze each of these cases and see how we can use chain rule to solve problems involving those aspects. So example 1. Now look at this example. It says y is equals to 3x squared plus 4x minus 2 raised to the power 7. As long as I have a power, I should know that I'm dealing with what? Chain rule. So what I will do is I'm going to represent everything inside the bracket by any variable of my choice. I can use a x, I can use a z, a w, as long as it's no y, so that to avoid confusion. So I'm going to say that let u be equals to what? 3x squared plus 4x minus 2. So I've represented it with that. So if I have to rewrite it again, this function back, I'm going to have y equals to, so I'm writing everything here. I will now put u, then to the power of what? 7. It means that all my function inside here is now u. So when I'm writing it, I'll write u is power 7, right? So what I'll do is I'm going to differentiate two of them. So first of all, I'll differentiate u related to x. So if I should write, I will say that my du all over what? Dx will now be giving me as, if you differentiate 3x squared, you'll be having 6x. I've explained that in my earlier video. And if you differentiate 4x, you'll be having 4. Because this is a constant, you ignore it. That is, I differentiated u related to x, so I'm having this. Now the next one we'll differentiate will be this. So I'm going to have my the y move up. I'm going to have my dy all over what? The x or the u. I have my dy all over what? The u equals to, now this is u7, so to give me 7 u6. Now this is what I'm having. So what I'll do is I'm going to multiply both of them. That's what chain rule is telling us. We multiply the difference, the differentiation of what? Of both of them. Now when you differentiate this, so I will now say that the y all over what? The u multiply by the u over what? The x. Now if you look at this u equate this u, what will have in left? What will be left will be what? The y over what? The x. So we're looking for the y over the x. Now what is my dy over the x? My dy over the x will be, my dy over the u will be 7 u6 multiplied by my du over the x is what? 6x plus what? 4. Now from what we have here, is ending by writing this to be equals to my 7. What is the u I have? U is giving us my u is giving us 3x squared plus what? 4x minus 2. So I'm going to write it by saying into bracket 3x squared plus 4x minus what? Minus 2. But there's a power there, and I'll put my 6 multiply by If I put the multiplication here, I will have what? 6x plus 4. So this is what I'm having. I cannot multiply this 7 with all this function here, right? Because of the power. The only way I can multiply 7 is when I expand it, and that will take our time. So what I'll do, I can multiply this 7 with everything here because this just only have 1, right? So I'm going to say this should be equals to 7 times 6, 42, right? I multiply 7 times 6 is 42, so I have 42x plus 7 times 4 is 28. So I will have in this into bracket 3x squared plus 4x minus 2 to the power of what? 6. Assuming this has the power of 2 now, it will be very difficult to multiply. So either I leave it this way or I leave it this way. Any choice. The choice is mine. That is case 1. This is case 1. Now let's look at case 2. Case 2. Let's move to case 2. Now, for case 2 is when I have a root sign. It can be a square root, it can be a cube root, but in this case, I'm having a cube root. So first of all, I'll know that this recall, if I have a and the root sign here is, let me say, y, and this is z. So this will give me a, whatever is up will remain up, whatever is inside there will always come down here. This is what we have now. So if I want to do that, my y now will now be equals to, I'll write my 6x cubed plus 4x, open a bracket, whatever is up here, what is up is the one that is there. Since there's nothing up is the one that is there, then all over whatever is inside there, which is what? 3. So that's what I will be having, right? So from here we've gotten this. Now you're going to represent this that's giving us what we have earlier. So we represent everything inside here by a function. So let me use another function by a variable. Let me use another variable now. Since I used u the other time, I can use w this time. So I will say that let w be equals to what? 6x cubed plus 4x. Are we good? Now, if I've said w is this, so if I want to write my function back, my y will now give me w1 over. So we have y equals to w1 over 3. Now what will I do? I'm going to differentiate this. So if I'm differentiating, this is w, this is x. So I'm differentiating w with respect to x. So I'm going to have the w all over what? The x. And that will give me, if you differentiate this, I'll be having 18x squared. Watch my previous video, you get to understand this. Now, plus, differentiate this, we'll be having just 4. Now from here, this is what we have. And also I will now differentiate y with respect to what? W. So I'm going to have that. The y all over the w will now give me 1 over 3 w 1 over 3 minus 1, right? So when you do 1 over 3 minus 1, let's see, my 1 over 3 minus 1, LCM here is 3, this is 1 minus what? 3, right? Having minus what? 2 over 3. So this will now give me 1 over 3 w minus 2 over 3. Now if this w minus 2 over 3 is coming down, we will now say that this will now give us 1 all over 3 w 2 over 3, because whenever indices, if it's coming down, the minus will disappear. So we're having this. So now I will now multiply both of them. So I will say that the w all over the x multiplied by the y all over the w. I'm multiplying these two. So if you see that, the w is going to equal the w is remaining what? The y over the x. So equals to what? The y all over what? The x. So if we move forward, this will now give us this. So what is my dw? My dw here will be 18x squared plus 4. 18x squared plus 4 into the bracket. And my dy over the w give us what? Times 1 all over what? 3w2 over 3. Right? So this is going to give us this. If I multiply this, I'll be having 18x squared plus 4 times 1 will give you 18x squared plus 4 all over 3w. So what is w? W that I calculated here is giving us what? 6x cubed plus 4x. So I'm having 6x cubed plus what? 4x. So to the power of what? 2 over 3. 2 over 3. So this is my answer. If I like, it is not compulsory, I can say that what? My 18x squared plus 4 all over 3, and I can put this into 3 will be here, and I'll have 6x cubed plus 4x, right, to the power of what? The power of 2. I can put it this way if I like, but this is my answer here. So that is case 2. So for case 3, so we have trigonometric functions. Now for instance, if I say that my y is equals to what? Sine 4x, and I want to differentiate it. You should know things like this. You can use chain rule to solve it. So what I'll simply do here is that I'm going to represent what is in front of my sign with a value, with a variable, because we know we'll take it into the lowest form. So I'll say that I can use whatever I like. I can say let p be equals to what? 4x. So whatever I like I use, right? But you have to be very careful when you use whatever you like. Now this is p, so I will now say that my y will now be equals to what? Sine what? Sine p. As I've already said, this guy here is p. Now differentiate the p with respect to what? X. So I'm going to have the p, right, all over what? The x. So when you do that, so we have that. So the p over the x will give me 4, right? And also the y all over the p, because differentiating y to p will give us, when I'm moving from sine, we'll be having cos. Differentiate sine p, you have what? Cos p. Differentiate sine x, you have cos x. So we're dealing with p this time. And I'm going to multiply both of them together. So in multiplying both of them together, I'm going to say that the p all over the x multiplied by the y all over what? The p. And this will give me what? P will equate the p over the p, so we're left with what? The y all over what? The x. Right? So if we move forward, what is my dp over the x? My dp over the x is 4, and my dy all over the p will give me cos p. So times what? Cos p. Now what is p? P is what? 4x. So we're having cos what? 4x. 4 cos 4x. Right? Now we move further. So whatever you have in front of the value, whatever you have in front of what? Of the value, represent it no matter what it is. So now you'll be having this. Now case 4. Case 4. Case 4. Is when you have logarithmic equation, or would I call it exponential values. For instance, now if I say my y is equals to what? E raised power what? 4x squared. So what I would say is that what? I will represent this up here as actually any variable of my choice. So I'm going to say that let's I can use t, whatever I like, is equals to what? 4x squared. So if I want to rewrite this, my y will be equals to what? My y will be equals to what? E to the power of what? T. Right? Because I've already said this guy is what? T. So if I differentiate each of them, differentiating, I will say that my dt all over what? The x will give me 8x. Right? And the y all over what? The t will give me e to the power of t. So when you differentiate et, you have et. Call it exponential t. They call this symbol epsilon. Right? So this is what we have here. Now whenever I differentiate it, it will always give you back what you have. So from here, what I will do here is this. I'm going to multiply these two as I've been doing before. So multiplying both of them, I will say the t all over what? The x multiplied by the y all over what? The t. This will give me the y over what? The x. Because when these two equal to each other, it's remaining that guy. So from here, this will now be equals to this. So we have so what is my dt over the x? That is 8x. Multiplied by, what is my dy over the t? That is et. Right? So this will now give me 8x e. Then what is the t here? The t is what? 4x squared. So that is my answer in terms of exponential value. So irrespective of what is written here, right, always represent your value, whatever you have on the e, by any variable of your choice, and you follow the same procedure. Now let's see case 4 when we talk about logarithmic values, right? Now case 4. So for case 5, let's say y is equals to what? The ln of what? 3x squared plus 4x minus 2. Right? So what you do is you're going to represent whatever you have inside here by any variable of your choice. So let me just use z for this time. So I say let z be equals to what? 3x squared plus 4x minus 2. Right? So if I now rewrite this, I will now say my y will now give me what? Ln z. Now if you differentiate this z with respect to what? X, I will say that what? My dz all over what? The x. Right? And this will give me 6x plus 4. This is a constant. And the y all over what? The z is going to give me 1 over z. So whenever I differentiate the ln of something to give you the inverse of that thing, right? So the lane of something will always give you what? The inverse of that thing. So if I say the lane of y, if you change the lane of y, it will give you 1 over y, the lane of w, 1 over w, and so on. So I'm going to multiply both of them. So I will now write that my dz all over the x multiplied by dy all over the z. This is going to give me, I know this will be my what? Dy over the x, right? So when you multiply the z, when you have the z over the x is what? We have 6x plus 4, right? Then multiply by dy over the z is 1 all over what? Z. So if you multiply these two, this will now give us that my dy all over the x, 6x plus 4 times 1 give you 6x plus 4 all over z. Then what is z? Z is 3x squared plus 4x minus 2. So that will be our answer. Are we good? That will be our answer for case 5. Now let's look at this example. It says y is equals to ln 5x squared plus 3 to the power of 4 over 2 to differentiate. So one thing you need to understand is that what? In front of this, the ln, whatever is in front of it, you represent it with any variable of your choice. So I'm going to say that let u be equals to what? That will give me 5x squared plus 3 to the power of what? 4. That's what we have. So if I want to write it, my y will be equals to what? Will be equals to ln what? Ln u. Abi? Now, from here, I'm going to differentiate this. So differentiating this variable, I'll say that my du related to what? Related to what? Dx will give us what? What will it give us? Now look at what will happen here. This on its own is a function on its own. So let me do it somewhere here. So we know that if u is equals to what? 5x squared plus 3 to the power of 4, right? So we have here. Then I will now say that let w be equals to whatever is inside there. This is what we've been doing since. Plus 3, right? So if I write this, it will become u is equals to what? 5. U will be equals to what? W raised to the power of what? 4. Now differentiate w related to x. So I'll say that my dw all over what? The x will give me 10x, right? And my du all over what? The w will give me 4w cubed. So if I multiply both of them, the w over what? The x multiplied by the u over what? The w. That will give me the u over the x, because the w will equal the w, we are left with what? The u over the x. So what is my dw over the x? That is 10x. What is my du over the w? That is 4w cubed. So what I will simply do here is that I will say my du all over the x, my du over the x will now give me 10x multiplied by 4, right? What is w? That's 10x multiplied by, let me put this times here, 4. What is w? W is 5x squared plus 3, and it has cubed on it here. So we'll now say that my du over the x will give me this 10 times 4 is 40, so we have 40x, right, into bracket 5x squared plus 3 to the power of what? 3. That's what we're having. This is just my side working. So from here, I'll differentiate the y over the u. So the y, the u it's going to give me 1 all over u. So division of length of any variable will give you an inverse of that variable. So I will now say that my dy over the x will now give me du over the x multiplied by what? Dy over what? Du. So what is my du over the x? Du over the x is 40x into bracket 5x squared plus 3 to the power of 3 multiplied by dy over the u is 1 over u. So 1 all over what? U. So this will now give me that my dy over the x will now be 40x into bracket 5x squared plus 3 to the power of 3 times 1 will give you 40x into bracket 5x squared plus 3 to the power of what? 3. Everything over what? U. So what is u? U is 5x squared plus 3 to the power of what? 4. So that will be my answer, because my u is this, right? So this is my answer here. This is how we apply some of a typical example. So if you find this video helpful, don't forget to click on the subscribe button. Thanks for watching.